All right, so graphing. The shape of a graph of a quadratic function is called a parabola, and there are two forms that we're going to learn. Two forms, standard form and factored form. Sorry about the repeat. Sorry, lo siento. Okay, so here's what I know. When I think about a parabola, if A is positive, the graph opens what? Up. The graph opens up. And I remember it by, if you're positive, if you have a positive outlook, you smile, right? Your graph looks like a smile. Okay, it looks like a smile. So if A is positive, your graph is going to open up, it makes a smile. If A is negative, if you're having a bad day, probably not going to smile. The graph is going to open down, and that looks like a frown. Yeah.
Frown the clown.
Opens down, makes a frown. Sad face. Okay. So that should be easy. Positive makes you smile. It's going to open up. Negative, frowny. Okay. All quadratic equations have a vertex. Logan, is that you? I'm making you teach the class. Which is the turning point of the graph. So if I think about my parabola, the vertex is going to be right here. Or if it opens downward, the vertex will be right here. The vertex is also called a minimum. We'll say that in a second. Or a maximum, yeah. But that's farther down. I just want you to remember that. Okay. Quadratic graphs are symmetrical across the Speak a little bit louder so the kids at home can hear you. I'm serious, so we can pick you up on the recording. Which runs through the blank above it. Yeah, it runs through the vertex. The axis of symmetry goes right through the vertex. So the axis of symmetry is some line, some vertical line that's going to pass right through the vertex. So that means that it's going to end up as a vertical line, and all vertical lines are the equation x equals some number, right? So the formula to figure out what the axis of symmetry is x equals negative b over 2a. We've done this before. You guys did well with this, but I'm going to highlight this because this is super important. Okay. The quadratic function crosses the y-axis. When do we cross the y-axis? What's that called when we cross the y-axis? It's called the y-intercept, yeah. So, no, it's not your vertex. So I want you to look at this function. All right, this is a standard form. God bless you. Standard form. So the quadratic function crosses the y-axis at C. This number right here, as long as it's in standard form, tells you where it crosses the y-axis. So Logan, yesterday when we were graphing and like I was just sketching graphs, remember I put something at a negative 15 or positive 18 or something and you're like, 18, where'd you get that? And I was like, oh, I multiplied those last two numbers together. So if it's in factored form, you have to multiply the two constants together to figure out what it is. Okay. The y-intercept always has an x value of 0. Yeah. For a parabola, the y-intercept will be the ordered pair 0, comma, C, right? Because remember, it's the whatever that constant is in the C position. So this is telling you the number. This is what this is saying. This is telling you the number of solutions possible. That's what this next blank is referring to. So a quadratic can cross or touch the x-axis. Yeah, 0, 1, or 2 times. If it crosses 0 times, that means what? Well, if where it touches the x-axis is the solution and it doesn't cross it at all, then that means it has what? No solution. If it just touches it one time, that means it has one solution. Yeah, and it's the vertex. Good job. I'm going to write that. That's perfect. And if it crosses 2 times, that means it has 2 roots or solutions. Okay. I'm going to pause for a second and let everybody catch up. Take a drink. Someone has been sick with a sore throat, like runny nose, something, and has given me their germs. Daniel, I was feeling fine until you came back yesterday. So I'm blaming you. Are we all good? Okay. All right. So we're gonna practice graphing these. So we're gonna look at this graph first. So I took a screenshot of this. Like this is just an embedded screenshot off of Desmos. So this is the ordered pair -3, 0. And I think the rest of them are visible. But we're trying to find the vertex. So the vertex is this point right here. So the vertex is -1, 4. Yeah. The axis of symmetry, well, that's a vertical line. Remember I said it's a vertical line. So I'm going to just sketch it so you can see it. It's this dashed line right here. That's going to go through the vertex. We said it goes through the vertex. And all vertical lines have the equation x equals something. Yes, x equals -1. Why did you choose -1 instead of 4, Logan? Yeah, and it's going through the x coordinate. The x coordinate is -1. The y-intercept is the ordered pair 0, 3. The x-intercepts are, those are my roots. What is it? Yeah, good job. -3, 1. I thought you said 3 and 1. So the quadratic equation in factored form. Let's think about this. So if my root is x equals -3, the factor started off as what? If the solution is negative, the factor was positive, opposite. So how do I show this as a factor? Well, I'm going to write x plus 3. Right? That's what that came from. And for this solution right here, this is the solution x equals +1. So if the solution is positive, that means its factor was negative, x minus 1. So we're really close, except remember I said, so if you think about this, if I take these two numbers and multiply them together, I should get my y-intercept. Do I? Is +3 times -1 equal to +3? No. So that means that we're missing something out here. And what we're missing is a -1. And that makes sense because this graph is frowning. So we have to have a negative out in front to make it frown. And now when I take 3 times -1 and get -3 times another -1, I get the +3 that I'm looking for. So we're just going to take this right here and we're going to write it in standard form. So that means we have to FOIL it. So we have to FOIL this and then multiply through by the negative. So I have x plus 3 times x minus 1, and I'm going to FOIL it. X times x is x squared. X times -1 is -1x. 3 times x is positive 3x. 3 times negative 1 is negative 3. And then what do I have outside of all of this? No, what's this? A negative 1. So I'm going to have to multiply everything by a negative 1, and I'm going to do it right now. So negative 1 times x squared gives me negative x squared. A negative 1 times a negative 1 gives me a positive 1x. A negative 1 times a positive 3 gives me a negative 3x, and a negative 1 times a negative 3 gives me a positive 3. Combine these two terms right here. What does that become? What is 1x minus 3x? Negative 2x. So y equals negative x squared minus 2x plus 3. That's your equation in standard form. We had to FOIL and then multiply everything through by the negative. So I'm going to just label all the pieces. A is negative 1, B is negative 2, and C is 3. Remember, C is your y-intercept, and that is where it crosses the y-axis. A is negative, so your graph is going to open down, and it does. Okay. Questions? Okay, I'm going to leave that there for a second, and then we're going to flip over and graph 2 of them. Okay, are we all good? Kaden, are you writing any of this down? You're osmosing it through your back brain? Okay. You wrote it down? You're amazing. Thank you, sir. All right, graphing in standard form. So this first graph right here has to be written in standard form. Is the function written in standard form? Is the equation in standard form? Yeah, it is. Okay. So the first thing that we have to do is find the axis of symmetry. That's our dashed vertical line. So it says that we need negative b. So what is the value of b? What is b? It's 9, right? B is 9. So I'm going to put negative 9. So I want this negative moved right here. I'll move it up. And then 2 times a. 2 times, what is the value of a? 9. So 2 times 9. So that gives me negative 9 over 18. And that reduces to negative 1/2. So that's the first thing I'm going to do. The first thing I'm going to do is I'm going to go to my graph, and I'm going to go to where x is negative 1/2, which is right here, and I'm going to draw my dashed line. You should also do that. Graph your axis of symmetry. You want to graph your axis of symmetry. Are you guys seeing me draw this on here? The vertical line at x equals negative 1/2. It's not x equals negative 1, it's 1/2, so it's smaller than negative 1. So plot that point first. This is your axis of symmetry. Maybe I should make it in red so you guys can see it a little bit better. Okay. Are we good with that? So now we're going to find the vertex. And in order to find the vertex, it says you plug back the x equals. You're going to take this value from the axis of symmetry and plug it back into the equation. So we're going to find f of x. Well, the x is now going to be negative 1/2. So I'm plugging that axis of symmetry value back in. So that means I have to take negative 1/2 and square it. And I have to take negative 1/2 and multiply it by 9. And I'm going to do all of this in my what? In my calculator. I'm going to do all of this in my calculator. So I'm going to do it all at once. So here's what I'm going to type in. I'm going to type in, I'm going to write that here because I just need to see it. So in my calculator, this is the operation that I'm using. Okay, so I'm going to take 9 times parenthesis 1 divided by 2, close my parenthesis, then I'm going to hit my caret function and the number 2. And actually, this needs to be a -1. Sorry, -1. Okay, so 9 times parenthesis -1 divided by 2, close your parenthesis, caret squared. Are we there? Plus 9 times parenthesis -1 divided by 2, close your parenthesis, -4. So 9/4 plus the -9/2.
Where's the caret symbol?
Pardon me?
Where's the caret symbol?
It's right above the divide sign.
What is it?
Did you find it?
Yeah.
What did we get? Did you get a decimal, right? Did everybody get negative? What'd you get? Yeah. So when f of x is -1/2, this is the same thing as saying y equals -6.2. That's what you should get there. So we have to graph that. We have to plot that. Let me look and see what you did. We're not doing that today. Okay, we're not doing that at all. So it says divide up there. You see it's there it looks like a minus back here, but there are 2 dots above that. We're dividing, we're making a fraction. So this should be a divide symbol. So you divided here, but this is also a division symbol right here. Divide. Okay. You can't see the dots over it, but it's divide. All right. So let's write our ordered pair, but I probably left that up there. So our ordered pair, our vertex is going to be at -1/2, comma, -6.25. So that means I'm going to go all the way down here and right below the -6 line, I'm going to put a point. That's going to be my vertex right there. So that means that my graph goes up from the right of that and up from the left of that. Okay. So it's asking us to identify key features. So is A positive or negative? Look at our graph. Our equation is A. When you look at your equation, is A positive or negative? Positive. So I would just write a plus sign here. A is positive. A is positive. It's a +9, I think, right? Yeah. So it's a +9. What is B? It's also a +9. And what is C? A -4. Well, this tells me that I'm going to do what? What does C tell me? What does C represent? C is my y-intercept. Okay. So it says the parabola will open up or down. A is positive, so it's going to open up. And because it opens up, is it going to have a maximum or a minimum? Is the vertex going to be the highest point on the graph or the lowest? The graph is going to go like this. Yeah, so the vertex is going to be the lowest point, meaning it's a minimum. Okay. We already wrote this down. We said, well, the axis of symmetry is at x equals -1/2. Our vertex is right here. We said our vertex was -1/2, comma, -6.25. And we know that the y-intercept is the ordered pair what? Well, it's 0, -4. It's the ordered pair 0, -4. So let's talk about what the axis of symmetry does for us. The axis of symmetry lets us use that as a fold line. You guys remember that? It's a fold line. So this graph crosses the y-axis at -1, 2, 3, at -4. How far away is this point from the axis of symmetry? How far away is this point right here from this line? It's half of a unit away, right? It's that magical fold. So that means I can go half a unit on the other side because they're mirror images. They're symmetrical. So if it equals -4 here, it equals -4 there. Okay. What happens when x is 1? Do we know? Can we figure it out? What happens when x is 1? How do I figure that out? Well, I'm going to start with 1 as my x coordinate. And I'm going to go to my calculator. And I'm going to type in 9 times parenthesis 1 squared plus 9 times, parenthesis 1 minus 4. I'm just plugging 1 in for x. Do that. 14. When x is 1, y is 14. When x is 1, y is 14. That goes off of our graph. So what do we need to do? We need to pick a point that's less than 1. You need 5 points. So what point is in between 0 and 1? What'd you say? Yeah, 1/2. So let's pick the point 1/2. Okay, so same thing. In your calculator. 9 times. You guys have to do this. So 9 times 1/2. Quantity squared. I'm going to write this nice and dark so you guys can see it. 9 times parenthesis 1 divided by 2, close your parentheses, squared, plus 9 times 1 divided by 2, close your parentheses, minus 4. What do you get?
2.75.
2.75. Did everybody get that? Yay or nay? So when x is 1/2, my output is 2.75. So let's see. When x is 1/2, I'm right here, and I'm going to go up 1, 2. 2.75 is almost all the way to the 3. Almost all the way to the 3. Do you guys see that? I'm putting it right below it. How far away is this point from the axis of symmetry? What's this distance? It's 1 whole unit away. So I'm going to go 1 whole unit away in the opposite direction. Do you guys see that? Do you see how we use the axis of symmetry to guide our thinking? So this is going to be a skinny little graph that looks like this. Maybe I have a blue. Maybe it'll show up better on blue. Something like that. Okay. I know we don't like graphing decimals and fractions, but it's important to work with them because rarely do you have nice integer answers. Rarely. Okay. We're going to do one more and then we'll get started on our activities. One more. So this one we're going to use what for it? What are we going to use this one for? What are we going to do this one with? Yeah, we're gonna use this. We're gonna use Desmos with this one, okay? So I'm gonna go to Desmos right here. I'm splitting my screen. We're still gonna fill all of this out. But in Desmos, I'm going to write out this equation right here. So y equals negative 2x squared plus 13x minus 15. So let's talk about all of the things we know. What is the equation for the axis of symmetry? I know it's going to be the x coordinate of the vertex. So what is the vertex? Do you guys see that? What is the x coordinate? Yeah, x equals 3.25. The numbers that you put in here are going to be negative 13 and negative 2 times, sorry, and positive 2 times negative 2, which gives you negative 13 over negative 4, and a negative divided by a negative is a positive. That's how you figured it out, but really we didn't. We just used our graph, okay? When we take this value of 3.25 and we plug it back into the equation, what's our output going to be? What's that number right here next to the vertex, like the vertex ordered pair? What's the output, the y value? 6.125. So the vertex is the ordered pair 3.25, comma 6.125. Do you guys see that I'm just using this point right here? I'm just using this point right here. 3.25, comma 6.125. I'm letting Desmos figure that out for me. I'm not doing that on my own. I'm letting Desmos do it. Okay. Are we good with that? Okay. I'm going to move up a little bit. So let's talk about the key features of our equation. Well, what is the value of A? What's A? It's negative 2. What is the value of B? Positive 13. What is the value of C? Okay, what does C tell me? Yeah, this is my y-intercept. Don't forget that. It's important. So because A is negative, is my graph going to open up or down? Well, which way is that graph opening? It's opening down. Yeah, it's got a frowny face. So that means that this point right here, the vertex is a maximum. Yeah. So it says, hey, what's the equation to your axis of symmetry? X equals 3.25. Where's your vertex? Well, I wrote it right here. Right? Your vertex is the ordered pair 3.25, comma 6.125. And I didn't do any of the math. I let Desmos do all of the thinking for me. Where's the y-intercept? Well, I'm going to drive my graph. I'm going to see if I can move my graph to find the y-intercept. So can I get rid of that? Possibly not. How do I get rid of the pen? Any ideas? Anyone? Dang it. Well, I can't even make it move right now. Maybe if I use no. I can't get rid of the pen that I clicked on, so it's not going to let me move it. But we know that the y-intercept is 0, negative 15. We know that because that's what the value of C is. We just need one other point. Doesn't matter what point we choose. Yeah, I hit it. It's not working. It's not letting me get rid of it. It's letting me clear the ink, but it's not letting me get rid of the pen. Okay. So doesn't matter what point we choose. We just need one other point. We've got this one. We've got our y-intercept down there and its mirror image. What other point can we choose? Any of them, right? So let's see what this point is. Here we go, mouse. What is this point right here? I'm trying to get to where, like, maybe I've got a whole number somewhere. That's close. What's this point right here? We're going to use this point. This is the ordered pair 2.16. I'm moving it. Hang on a second. Okay. We're going to use the 1.5 and 0.028. 1 point, what was that? Sorry. 1.50. 1.50. That's one of my roots. And my other root is what? Can you see the other root? It's 50. It's 50. And I know that my axes is being counted by pi because that's what I'm doing with my other class. So don't let that flip your brain out. Okay. So I'm just going to graph these points and make my graph. I've got everything that I need to know. So I'm going to get rid of this guy, make this big again. So let's see. We set our y-intercept and our vertex is 3.25. So 3.25, 6.125. So it's going to be about right here. That is where my vertex lives, right in that little tiny corner, right in that little tiny corner. I know that it crosses the y-axis at -15, which isn't even on my graph, but I'm going to pretend this is -15 right here. And I'm going to go over 3.25 this way and put another -15 because my axis of symmetry is right here. I'm just kind of splitting the difference. I'm just sketching it. So I'm splitting the difference. Your vertices, like your, remember we want this distance to be the same. So maybe I should move that over a little bit. But. Okay. So now I'm going to graph these other points. So I have the point 1.50. That's a root. And I have the point 50. That's also a root. And that gives me enough information to connect all my points and make this beautiful little graph. It's a sketch. It doesn't have to be perfect. You're just sketching it with the points that you've written down like that. Okay. Thoughts? Okay, I'm going to freeze the screen so you can look at that while I try to find our little video maker. See if it's still working.